What? Let me try with some magic words like last time. It sort of worked. Sort of. Remember, Izzy Wizzy, Bob's your auntie. It's like magic. Right, all jokes aside, the time has come to assemble this circuit board. Greetings, the Astro 30 here, and I'm working on this ElectroInida 200 watt power amplifier module. But first, I'm going to have to drill 2 mounting holes. Okay, so I want to get this as accurate as possible. As I said, I'm going to drill into the ground plane, so I'll make it 10 mil up should be fine. So roughly somewhere in the center. Well, actually no, I might make it 10, 12 mil. Put a little dot, which I will get rid of later. I'm just going to double check that that is 12 mil. Yes. I'll do this off camera and I'll come back with what I've got. Okay, after messing around, I've got it 15 in from each edge, 12 up. And that gives us a centre to centre of holes of roughly 90. So now I need to drill them. Okay, now I'm going to drill them to 3.2 mil, and I'm starting at 3.2 mil, which you shouldn't do. But it would be much more helpful if the drill bit doesn't wander. Jeez. Jeez, for a circuit board, that's hard. That's what she said. Okay, that's one. Right, I didn't want to have to do that, but it is what it is. Okay, so now I want to deburr the rough copper off the edge of the board here. So I just take a larger drill bit, just do that. And that. Same on the silkscreen side. There we go, deburred. And yes, it's close to this connector. Will it still clear it? Yes. It's fine. Probably could have come in a little bit further. But now at least there is mechanical strength in mounting this board. Right, it's time to assemble it. Oh, excuse me, I farted. And between hole center to hole center we're looking at 88, so that's pretty good. It's not bang on exact measurements, but it's pretty damn close, and at least it's within a millimeter. It's not like off by half a millimeter, so my judgment wasn't too bad. That's what the old adage is: measure twice, cut once. Oh, my measurements are so bang on. Oh, suit you. Oh. Okay, so it's assembly time. So I'm going to start with the power supply because, well, I'm going to need it. So I'm just going to put these capacitors in and hope that they stay there for me, which they probably won't. It started already. Okay, stay there. Might just start with the two of them, because that one wants to keep falling out. That one just fell out. Okay, use that capacitor to prop the board up for me. Alright, let's get dangerous. I love the smell of solder. Okay, that's perfect. Now we go there. That's the power supply completed. Those capacitors look kind of wanky on the board, but yeah, that's what it would have looked like Danish Dart with those 4 small capacitors on it. Although I did like the picture you sent me of the capacitors you stuck on yours. That's epic. Alright, moving on. Okay, I'm going to start assembly on this ElectroInida board now. I like to start with the lower profile components first, such as resistors. And someone was nice enough to mark on the end of the resistor tag band here what the resistance is, if you can't be bothered reading it. However, I've got a meter up here on the desk ready to go on the wrong scale, of course. Wrong thing. But that's not even what I wanted. I wanted that, you idiot. Alright. Let's see. Let me just adjust the speed of that to high. 46. Close enough. Okay, I'm not going to film the whole entire process assembling this because it's not going to be that exciting. Plus my hand's going to be constantly in the way. I will just take bits of video as I go and we'll check back in regularly. This is the first time I've assembled a kit in a few years. Well, it's not really a kit, but because the parts were supplied to me, kind of makes it like a kit, if you know what I mean. But again, thank you to Danish Dart for sending me this. Now I'm putting all the colour bands the right way round that match the text so the electrons don't fall out. And the reason you do the low profile components first, like the resistors, is because it's easier to lay it flat on the desk to solder it, you know, so that it's actually flush with the board. I knew that was going to be a pain to solder because there's just way too much copper here. Yeah, it's going to be real fun. Well, I got one in. Might want to increase my temperature to about 430, I reckon should be enough. I'm only going to need one of these 10kRs, the other one's for the LED. I'm not putting the LED on the board, so because I don't really need it. I seem to have this lonely 47 ohm resistor which I can't see where it goes either. Oh, there it's up there. I found it. Wondered why there was 3 and I can only find 2. Okay. Brown, black, black, black. 10 kilo ohm in the 5 band thingo. This soldering iron's working great, and I need to get a stand for it because yeah, it's just sort of floating around the desk here, which is not ideal. Anyway, I'll keep on going with resistors and check back in shortly. So that's all the low profile resistors on. I've got these larger 100 ohm resistors which go there, there and there, but I want to know with these 2 watt 220 ohm resistors, why in the low areas such as on the input stage here you would choose a 2 watt device. That's just, you don't need it. Same with these 27 ohm resistors. That's what I got for that. But this is in the high current path, so that makes sense. But the 2 watt ones here, here and here, it's not necessary. Quarter watt, half watt would have done, but these look like 2-watt devices. That's a big beefy 10 ohm resistor. So the only joint I'm not happy with on this whole entire board is this one here. That one right there. It ended up being a bit messy. Yeah, I'm not sure what went on there. I mean, it looks alright, but it's still physically connected. It is just a really crappy looking joint. Now I'm going to install the 220 ohm resistors, and I'm going to install the ones in the high power area, like the VBE multiplier, and near the output stage, a little proud of the board. I will demonstrate what I mean when I come to that. It just, in case they get hot, they can scorch the board, which will result in, where it's scorched, becoming conductive, causing a short circuit and causing other problems. And trying to fix it or find it can be challenging, especially trying to clean up the scorched area. However, before I paint myself into a corner, I might stick these two 1N4148 or 1N918 diodes in these two places, because, well, it's going to need them, and this is in the constant current source for the input stage, so it's not really necessary to rise them off the board. Let's get going. Make sure to install these the correct way around, or else the circuit will not function correctly, if at all. So keep that in mind. Is anyone bored yet watching me assemble a circuit board? No? Well, thank you for continuing to watch up to this point. I would have done it in time lapse, that might have been more fun, but it's a lot more effort on my computer. Spending 3 or 4 hours trying to render out 2 minutes of video of time lapse, because it's kind of annoying and I've got other things to do. So the quicker a video can be edited and rendered out, the better. I love how this meter in the background, the O1, keeps beeping every 5 or 10 minutes to tell me that it's still on. Thank you for that. That was wonderful. I need to make a correction. Where I said this is the VBE multiplier, it's not. This is not the bias pot. This one's actually for the DC offset. So having 2-watt 220 ohm resistors here is totally unnecessary. You could get away with just simply half-watt devices there. But anyway, as I got the parts for free, I'm not complaining. I'll just stick these ones close to the board because there's no point raising them up. That is what I meant about having them slightly proud of the board. I've got a good air gap of about 4 mil there. Should be all you need. Moving on. Some of these joints I've got to reflow. They're not very nice. Now I'm confused. I've got a 510 capacitor here and a 100 wherever that's gone. Now I'm supposed to have, that board's upside down, the electrons are going to fall out. I'm supposed to have a 47 picofarad and a 10 picofarad. With these, they're using the IEC notation. So that would make that 10 picofarad because it's 10 with 0 zeros after it. Because 104 is 10 with 4 zeros after it. So that would make that 10 picofarad. And this 51 0 would be the same. That would be 51 picofarad. I got confused. These are not ceramic, by the way. I got confused there for a sec. These should be perfectly right. If the amplifier fails to perform correctly, I'll change them. That should be a 10 picofarad. Which is not going to fit in there like that. I'm going to have to reshape the pins. 51 versus 47 picofarad here in the VAS transistor stage as the millicap. It's neither here nor there. 100 picofarad is usually the norm. But yeah, I'm just going with what I've got. So I've got the low profile capacitors in. I will now put the variable resistors in. Now I'm just installing the signal transistors, the BC546s and 556s respectively. Then I'm going to install my 1 microfarad capacitor and the 2.33 ohm resistors, and then I'm going to call it a day from here because it is getting late at night and I'm tired and I really need to get this video edited, and it's going to be in several parts as I said, so I'm just mainly assembling this as I go, bringing you along for the ride. I mean, you can take as about as much entertainment out of this as you like, but yeah, I am human, I can't keep going like the Energizer Bunny. I do have to get up at 6 o'clock in the morning, so that's always fun. Let's get these joints done, and then in the next shot you will see that everything so far will be assembled except for the large TO192s, I think they're called, but the MJE 340 and 350 respectively I'm going to install at a later time, and I'm not going to do the output stage yet either until I've got a suitable enclosure to mount this in, so I can proceed to the next stage, which is actually getting this to fit in something and get it adequate heat sinking. So that's why I'm not doing that in this video. Oh, that joint's shit. Danish Dart was even nice enough to supply the connectors that I hate. I mean, love. Yeah, these ones. So I'm going to install that as well. Might as well whilst it's here. And then finally those 2 large power resistors. That's the meter doing that. Just doing the 5 watt devices now, and we'll call it a night. Because this video is getting way too long just for putting an amplifier together. Although that joint was shit. I'll fix that in a minute when I cut it. It does take time to assemble things correctly. But hopefully in this video you've understood the method behind the way I actually decided to assemble things. Because as you see, I'm working on the desk without anything holding the PCB still, which is awkward. It can be done, but it's awkward. All my tools are in storage, so I don't have access to my helping hand tool. But that, it's upside down, electrons will fall out. That's what I've got to present. Okay, this is the next evening, and there it is there. I was really tired last night by the time I got to this stage. These 5 watt resistors are now in, and there is around about a 4mm air gap between it and the circuit board for the same reason these are raised, in case something goes wrong with the output stage and these resistors heat up, they'll scorch the board. Now there was one point I wanted to bring up about this VBE multiplier. Now the choice of the trim resistor originally was supposed to be 220 ohms, which is a non-standard value. Now Danish Dart has included a 501, which is a 500 ohm variable resistor. So he's actually increased the resistance by 280 ohms. Personally, I would have actually gone down to the nearest value, which is 200, because if you start increasing this resistor, it may or may not make the adjustment of this harder. However, as this VBE multiplier, bias spreader, rubber diode, whatever you want to call it, works, it becomes easier to adjust the higher this resistance is, but you can't go too high, then it doesn't actually adjust at all. So I don't know whether that 500 ohm variable resistor is going to be a problem or not, but that remains to be seen. Now I'm going to leave the output stage to another video. I am going to finish this off by putting the MJE 350 and 340 in respectively here on two heat sinks, and we'll call it a day on that. I do need to go out and get these two connectors, because Danish didn't supply them, obviously, because, well, I can go buy them myself. Anyway, let's move on to these transistors. And tonight's little condiment is a Great Northern, don't mind if I do. Right, now comes the fun, messy part. I don't know if I've got enough of this heatsink compound left, but I'll find out. I need a little bit. Yeah, I think I might just have enough. Might as well do the other transistor whilst I'm at it too, whilst I've got the thing in my hand. Oh, yeah, that was way too much. Perfect. These screws are probably way too long, which is perfect. That's the soldering on. So I'll pass the screw through the device. These do not need to be isolated because they're isolated from any other circuitry anyway. Yeah, they're slightly too long, but that's okay. Get that started. I'll probably wait to tighten that on the board so I've got the heatsink straight and all that sort of jazz. So I'll do the other one now. Okay, it's going to be slightly awkward to work around the tripod. I'll somehow hold that in, not quite like that. Alright, I'll do it a slightly different way. Drop the solder. As I'll hold the board up, solder my center lead, or at least one of the leads anyway. Just check. I reckon that's going to come into contact with that resistor there, so it's going to reheat that and pull it upwards about that far. Because in the ElectroInida assembly of this amp, they just cut the heatsink, and well, why not just, you know, raise the device up a bit? You know, it's not that difficult. Sure, you're reheating the joint, but at least, you know, it's not coming into contact with anything and you don't have to cut anything. So cutting something like the heatsink just seems dumb to me. But then, yeah, okay, whatever. Okay, it's kind of at a funny angle. Okay, now I can tighten the screws. Don't have to kill them, just tighten them. That should do that there. Now all I do is just make sure that those heat sinks are not coming into contact with anything, which they are not. Very, very good. And all I've got to do is just trim off this excess stuff on the bottom. Like so. I love it when it all flies across the room. Alright, well that completes assembly on this part of this video. Got the two transistors in, that's the VAS and that's the constant current source for said VAS. Now that's all that's left is the output stage and these connectors. Now I'm going to leave it to the next video so we can see how this is actually going to be mounted and what it's going to be mounted in, and then I may reveal what my plans are for this module. Anyway, I've been the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook. The link is in the description below. Anyway, this is the Astro 30 saying see ya.